Okay, let's talk about pulleys. Have a little pulley system set up. This first one is a simple pulley. This one is what we call a block and tackle pulley. And then this one is a different type of pulley altogether that we'll talk about. So first of all, a simple pulley. Let's go over a couple things. So how much force is required? This is a 1,000-gram mass. And the whole goal of a simple pulley is to just change direction. I'm gonna have to pull with that exact amount of force. It's not making it any easier or any harder. It's just changing the direction. If I wanna lift something, it's easier to pull on that rather than, imagine carrying it up a set of stairs. So another thing I want you to notice, for every inch of rope that I pull, this little block happens to be 1 inch. So when I clear that right about there, that distance that it just traveled was the distance between the tape right there. So it's a kind of like a 1-to-1 ratio. It's just a simple pulley. It's just used to change direction. So that has a mechanical advantage of 1. Another thing I want you to notice, if you look at this simple pulley, it's a lot like a first-class lever. Imagine if this is the fulcrum and it's the same on each side, and I drew a little picture of that. So there's that same pulley, and the blue line and the triangle, that's my fulcrum and my lever. So imagine it balanced on one side. So remember our equation for IMA is din over doubt. It's the same on each side, so 1 divided by 1 is 1. So a simple pulley, a fixed pulley like here, see how it's fixed up here? It has a mechanical advantage of 1. All right, moving on to block and tackle. Block and tackle just means an arrangement of several pulleys. So we have 2 fixed pulleys up here, and then we have 2 movable pulleys. So the way this guy works is it just has several strands, and I'm not sure if you can tell in the video, and you can come try this out in class. This is way easier to move. I'm only moving a quarter, and I'll explain why I said a quarter of the force required to lift this heavy weight. I'm only using a quarter of however much this weighs, that 1,000 grams. So if we count the strands, not counting this one, we have 1, 2, there we go. You can see right there, 1, 2, 3, 4. This has a mechanical advantage of 4. So I can count the strands, not the one that's in my hand. I can count the strands. Another way to think about it, so we have two fixed pulleys, right? Those each have a mechanical advantage of 1. And a movable pulley, if you think about it, a movable pulley is a lot like a second-class lever. You guessed it, I drew a picture of that too. So here's that second-class lever, the blue line and the triangle. And if you come talk to me in class, I'll be able to make a little more sense of it. So this is like a second-class lever, and a second-class lever has to have a mechanical advantage greater than 1. So every movable pulley has a mechanical advantage of 2. So we have 2 movable pulleys and 2 fixed pulleys. 2 times 2 is 4, and then 4 times 1 times 1 is 4. So that's another way to calculate your mechanical advantage. So that's why this one has a mechanical advantage of 4. Something else I want you to notice. If I put my block down here, remember it's 1 inch tall, and as soon as it clears it, it goes up 1 inch, but look how much rope I pulled. And when it was on the ground, you see the green tape right there? And when I lift it, that distance is 4 inches. So that's the trade-off. I have to pull a lot of rope, but it's way easier. Moving on. This one is also a movable pulley. So every movable pulley has a mechanical advantage of 2. And the way this one works, this is seen a lot in sailing, to make a sail really taut. And the way I have it set up is there's a spring here, and just kind of showing you how it works. But notice that is a movable pulley. So this one has a mechanical advantage of 2. So in this case, you would count the 1 in your hands. So you can either figure out the mechanical advantage by if it's movable, mechanical advantage of 2, or fixed mechanical advantage of 1. And that settles that. Or you can count the strands, but you just have to remember, since this one is immovable, you do count the strands.